on Friday, I'll probably give you like maybe 5 minutes to get a little unit circle and fill out as much of it as you want or as much of it as you can, okay? I would recommend adding on the tangents. If it were me, that's what I would make sure I would add on the tangents so it makes life a little bit easier. To at least one quadrant, I would say, I would add all the quadrantal angles, undefined at the top and the bottom, 0 on the right and the left. And then I would do at least like root 3 over 3, 1 root 3 on one quadrant, or like off to the side if you want to, but somewhere on there, I would add it on so that you can use that on Monday. Okay, which is going to help us 3, 4, 5. So number 1 and 2, it says the cosine is negative 5/13 and sine of theta is greater than 0. I know this is not a unit circle angle, so I know I'm going to set up a triangle. I'm going to put theta in the corner. Now, if I want it to go exactly in the quadrant where it makes sense, you can. I can like go left or up or down, whatever. But I could also just draw a triangle and make sure I put the sign on the right side. So you get to choose what you want to do there. But the fact that cosine is negative and sine is positive, if I go around your circle or in your quadrants, for cosine to be like negative, I have to go into the second quadrant or the third quadrant. But then I also need sine to be positive, and that happens only in the second quadrant, which means technically I'm moving left and up. So the left would be the negative, the up would be the positive. So you can either do it that way and then literally draw negative 5 and 13, or I can put like this, negative 5, 13, and face it to the right. It doesn't matter, as long as you know what the sign of what you're missing is, which is a positive 12, right? This 5, 12, 13 is one of your 6 trig functions. So whether you put, one of your triples, whether you put it in the quadrant where it goes or you just draw yourself a triangle, you got to be careful just to make sure your signs are in the right spots, okay? So the sign of this would be opposite over hypotenuse, or a positive 12 over 13, and the cotangent would be adjacent over opposite, which is negative 5 over 12. It will always give you enough information to know what that missing side's sign is. So it will always tell you either it's in this specific quadrant or this trig function has this sign, and then you know which one to pick. All right, for 3, 4, and 5, you've got 1, your whole, whether it's an even or odd whole number next to pi is a trick, or you've got your coterminals, okay? So 3 pi is an odd number, an odd pi, and that falls on the left-hand side of my unit circle. I could either count it out or I could know that trick, because if it's 3, it's not that bad, but if it's 13, you don't want to count to 13 pi. And I know at 3 pi or at pi, my tangent is 0. When I go to 4, it says negative 3 pi over 4, and we talked about this last week, but we didn't do a whole lot with it this week. If there are negative angles, first of all, 2 options. 1, go off the over 4, know that that coordinate point is root 2 over 2 and root 2 over 2. And then the secant would be the cosine flipped, which becomes 2 over root 2, which gets rationalized to 2 root 2 over 2, and the 2's cancel. So I just get root 2 for the value. And then I still have to know where that lies. So when you're dealing with a negative angle, you have 2 choices. Work clockwise to the negative 3/4, like that, which actually would not be that far. This would be a half, so this would be negative 3/4. Or find where it's positive, which I think is easier. Find where it's positive, which is in my second quadrant. Fold it like a hamburger, and it puts it into your third quadrant. And I know in the third quadrant, all students take calculus, tells me the t or the tangent is positive, which means the cosine would be negative, and so would the secant. And then you get to sine of 13 pi over 6, and this is not on your unit circle. I would convert this to a mixed number. 13 over 6 pi becomes 2, and 1/6 pi. Even puts you on the right-hand side, and then the first 1/6 is your pi over 6, and the sign there is positive 1/2. So obviously, the faster you know your coordinate points, the faster you understand any kind of negative angle or coterminal, the easier those questions are going to be, because what we do today, the graphing, takes time. You don't want to be stuck without time when you get to the graphing because you took a long time to do these things that could have been fast, okay? All right, questions on anything warm-up related? Yeah. So I converted it to a mixed number. 13 over 6 is 2 and 1/6, right? The even part of it tells me go to the right, so 2 pi is on the right. And then 1/6 is the first over 6. If it was bigger than a half, I'd go to the second one, but it's the first one. It's also a coterminal to pi over 6. Yeah, you could do it a couple different ways. All right, so 2, 4, 5 is the graphs of sine and cosine, okay? Unfortunately, it's like an awkward split where we're at. I normally would go one more section after this because that's secant, cosecant, tangent, and cotangent. So we will, like, this skill basically is going to end up being on this test and then continue on to the next test because that builds on it. But timing of testing days means we're testing Tuesday, so I'm stopping here. So your test will cover everything up till 4, 5. So 4, 1, 2, 3, 4, and 5, okay? This section is one of the sections that the process is not fast. It takes a while, but it is the same step-by-step process on repeat. So when you practice it, this is how you get more comfortable with these kinds of graphs. You'll really only get 2 questions on your test from this, but they're each worth 10 points because there's so many parts to it, okay? So the first is the sine curve, and the sine curve is what happens when I only look at the y's going around my unit circle. So if I had, I'll pull it in so we could look at it. If I had pulled in the unit circle and I asked you to take all the angles and plot them on the x-axis, so notice these are all the angles.
I found this on the web.
Oh, she's so helpful. Those are the angles, and then take the y coordinates, which is the sine, and make those the y's along this curve. Your sine curve would look like this, okay? We're going to do it again with the cosine, and the cosine we look at the x values, but for sine we look at the y's. So if you notice, at pi over 6, your sine is a half, which means the y there is a half. At pi over 3, it'd be root 3 over 2. At pi over 2, it's 1. Then in the second quadrant, comes back down again. It goes root 3 over 2. It goes 1/2. At pi, your sine is 0. Then it goes negative. It goes to negative 1/2, negative root 2 over 2. Or no, negative root 3 over 2, negative 1. And then it comes back up again in the fourth quadrant. Root 3 over 2, negative root 3 over 2, negative 1/2. And it ends up back at 0. That's how your parent function of sine is formed. We call this 1 period. For your parent function, 1 period is 2 pi. So from start to finish, I get this roller coaster shape. It goes up and it comes back down again. Now we're going to shrink this and stretch it and shift it right and shift it left and move it up and move it down, but in a very different way that you're used to. This is what it would look like if you had multiple cycles. The sine curve technically continues on forever in both directions. So if I had just asked for 1 period, it would have looked like this. If I continue it on, it looks like this. If I wanted one before it, it looks like this. And every time that cycle is created by going around your unit circle one more time. Most of the questions you will do, and on the test you will only give me 1 period or 1 cycle. But if it's like a multiple choice question or a standardized test question, it might ask you to give you more than 1. Okay, the first thing we're going to identify is our amplitude and our period. Our amplitude is half the distance between the maximum and the minimum values of the function. So this is really how high your wave goes. How high it goes up or how low it goes is your amplitude. You find the amplitude by doing the absolute value of A, and this is when y equals A sine. We're going to start with bx. We'll eventually add to it, but we'll start here. So the A is on the front. I take the absolute value of that A, and that is your amplitude. That's how high up you're going to go and how low you're going to go off your midline. The period is how long it takes to do 1 complete cycle, and the period is 2 pi over b. The b is what's in between the trig function and the variable. So in my original sine function, it's just 1, and 2 pi over 1 would be 2 pi, and that's how it takes exactly 1 full cycle is completed in that 2 pi. But this is how we adjust the horizontal shrink and stretch. Here's our steps. We're going to do these exact same steps every single time. We're going to start with the amplitude. So you find A, you take the absolute value of A, and that's your amplitude. You find the period, which is 2 pi over B. Then you're going to find there are 5 key points every time. The first one is at 0. The last one is the period. And then the middle 3 come from multiplying the period times a fourth times a half and 3/4. So that gets you 5 total points. Then you're going to look for a phase shift, and you will know it has a phase shift if there is something added or subtracted inside your parentheses. And we'll find that phase shift, and we will add it on to the key points if it exists. If it doesn't exist, we just keep our key points. Then we're going to plot the key points on a curve. So if I'm looking at an XY axis, I would get my 0, my period, and then my 3 key points in between. And then I would plot the curve. And the pattern for sine is it starts at 0, it goes up to the amplitude, it comes back down to 0, goes to the negative amplitude, comes back up to 0. And then I would connect my points. And at the very end, if there's a vertical shift, which we'll get to at the end, we would then take these and we would shift them up or down depending on our vertical shift. So again, we're going to do this on repeat. Start with the first one. Example 1, very simple, just says y equals 2 sine of x. So I start with A, and my A is what? 2. And the absolute value of that is my amplitude. So my amplitude is 2. Then I find B. B is in between sine and x. What is it? No, there's a 1 there. Good. And the period is 2 pi over B, which is 2 pi over 1 or 2 pi. Then I find my 5 key points. The first one is 0. The last one is 2 pi. And the middle 3 come from multiplying the period times a fourth, times a half, and times 3/4. So this simplifies to be pi over 2. This simplifies to be pi. This simplifies to be 3 pi over 2. The first one is 0. The last one is 2 pi. There should be 5. There are 5 key points. Then I'm going to mark them on my x-axis. First one is 0. Second one is pi over 2. Third one is pi. Fourth one is 3 pi over 2. And the last one is 2 pi. Bless you. You with me so far? Okay, then I mark on the vertical axis my amplitude, which was 2. So I'm going to go up 2, plot it, mark it, and down 2, and mark it. It doesn't have it. We haven't really talked about it yet. But this, if it had a phase shift in there, if there was something in the parentheses, I would have adjusted my key points. You're going to see that in a little bit. But there is no phase shift right now. So now I just take these points. It's a sine pattern. So it starts at 0. It goes up to 2, comes back down to 0, goes to negative 2, comes back up to 0, and I connect them. And there's my 1 full period of sine, or 2 sine x. Do we remember this? Yeah. Do you do it in regular? Does it seem familiar at all? Maybe? Okay. I don't even remember. All right. Now I get a half sine of 2x. Same exact steps. Go to A. What is A? A half. So my amplitude is a half. That keeps it, right? Absolute value. B this time is what? 2. So the period is 2 pi over 2, which is pi. There, again, there's nothing adding or subtracting inside the parentheses. It would be here. That's what's going to cause a phase shift. We're going to get to that. But there's nothing right now. So I take my period and I find my key points. The first one is 0. The last one is pi. And then I get pi times a fourth, pi times a half, pi times 3/4, which is pi over 4, pi over 2, 3 pi over 4. Last one's pi, first one's 0. And then I have 1, 2, 3, 4, 5 key points. Now, if I had given you a graph, like if I had given you an XY axis and I had marked this was 0 and this was 2 pi, then I would need to see these values closer together. This would actually be half the width of that. If it is an open horizontal axis and I didn't label it, then I don't care how far you space out your key points as long as you mark them, okay? So they could actually look the same as the other ones, like pi over 4, pi over 2, 3 pi over 4, and pi. Just realize that if this was 1 on a standardized question where it gave you multiple choice, technically those would have to be squished together, okay? 2, if it was on one in which I actually marked your x-axis, you would know that it would really happen in half the distance from 0 to pi. This time, my amplitude is 1/2. So I'm starting at 0, I'm going up to 1/2, I'm coming down to 0, negative 1/2, and then back up to 0. Questions on that one? All right, so now what would have happened had I put a negative on the front of this? What do you think a negative does to the graph? It flips it upside down, just like every other graph. So if I had a negative on this graph, everything would have been the same. My 1/2, my negative 1/2, except I would have started at 0, and instead of going up to 1/2, I would have come down to negative 1/2, 0, 1/2, back to 0. So if there had been a negative on the front, which is important because that's really all you have to do, is at the end, flip it. Questions so far? All right, this one, and if you pay attention to instructions, because sometimes you're like get going and you just want to do all the work because you're used to doing all the work. This one actually just asks for the amplitude and the period. So what is the amplitude? 3, and the period is 2 pi over what's b? Pi. And it's just 2. Can your period not have a pi? Absolutely. It would just be your x coordinates would not have a pi either. They would be at 0, 1/2, 1, 3/2, and 2. It doesn't have to have pi. Oh, actually, then it says, sorry, it does say graph the function. So if I did that, I was reading the other ones. This, my first one would be 0. My last one would be 2. 2 times a fourth is 1/2. 2 times a half is 1. 2 times 3/4 is 1 1/2 or 3/2. And then my amplitude is 3. 1, 2, 3, 1, 2, 3. Start at 0, up to 3, 0, negative 3, 0. Questions so far? All right, now let's talk about a phase shift. So a phase shift is the same thing as a horizontal shift. And just like every other horizontal shift, if I have something inside the parentheses and I am adding or subtracting to the x, it's going to cause a phase shift. If I subtract it, it causes a horizontal shift. If I subtract it, it goes to the right. If I add it, it goes to the left, just like all the other horizontal shifts, okay? So now what we'll do is we'll still find A, the amplitude. We'll still find B, the period. We'll still do the 0, 1/4, 1/2, 3/4, and the period. And then we're going to look for a phase shift. If there's a phase shift, I'm going to take my 5 key points and either add or subtract the phase shift to them to shift those points to the right or to the left. And then I will use those key points to make my curve. So look at example 4. It says determine the amplitude, period, and phase shift of the following, and then graph the function. So what is A? 2, which is your amplitude. What is B? It's the one next to the X, right? So the B is 4, which makes the period 2 pi over 4 or pi over 2. Now, if I put this against the parent function, what does that do to my graph? What happens if I were to put this compared to something that has a period of 2 pi? It would squish it. Good. It would squish it horizontally, okay? Think about what's happening. It's a translation, right? It's a transfer. And on the 4x is where your horizontal shrink would come. That's the same idea. All right, so now I'm going to take my key points. This first one's 0. The last one's pi over 2. And now I'm going to get pi over 2 times 1/4. Pi over 2 times 1/2. Pi over 2 times 3/4. And I get pi over 8. Pi over 4. 3 pi over 8. First one's still 0. Last one's still pi over 2. With me so far? Here's where it's different, right? So this time we have a phase shift. I know I have a phase shift because I'm adding or subtracting something to the x. So to figure out what that phase shift is, I can set this equal to 0 and solve for x. I'd get 4x equals negative pi, and x equals negative pi over 4. Now, it should make sense because if it's positive in the initial thing, it's going to shift it left. Now I'm taking that negative pi over 4 and combining it with each of the ones that are there. So this time I'm actually going to take these key points and subtract pi over 4 from each of them. If it was a positive pi over 4, I'd add them. If it's a negative pi over 4, I'm going to subtract them. And it shifts every single key point pi over 4 to the left. So for here, I get negative pi over 4. This becomes 2 pi over 8, so this is negative pi over 8. This is 0. This becomes 2 pi over 8, and I get pi over 8. And this becomes 2 pi over 4, and I get pi over 4. And now those are your 5 key points. I took the 0 and like this pi over 4, the one up here? Yes. You set whatever's inside the parentheses equal to 0, solve for x. Okay. That's your phase shift. All right, now I'm going to my graph. Okay, so plan ahead. If I look at my key points, I've got 2 to the left of my vertical axis and 2 to the right. So you need to make sure you have space, okay? And make sure you space them out equally. So 0 is in the middle. And then I can work my way left, negative pi over 8, negative pi over 4, and work my way right, pi over 8, and pi over 4. And my amplitude was 2, so I'm going up 2, marking that, down 2, marking that. And this time I'm starting to the left. My 0, 0 is here, then it goes up to 2, down to 0, down to negative 2, up to 0. So A, amplitude, B, period, key points, then phase shift, then plot them. Good so far? Yes? Yeah? Okay. We're going to come back to this one. Well, let's just talk about it because I'm not going to work all the way through. But notice that inside is just more complicated, okay? To find my phase, first of all, my period is 2 pi over 2 because the b is still 2. So my period is pi. But my phase shift, I would set this equal to 0. I'd get 2x equals pi over 2. And then I'd have to divide by 2 or multiply by a half. And my phase shift is pi over 4. So after I find my key points, I would then add pi over 4 to each of them. Does everybody understand that? Okay. All right, now everything we just did with sine, we're going to do with cosine. Cosine follows the exact same steps. There is one difference, and that is the overall shape of your cosine curve. If you looked at your unit circle and you went around your circle and you plotted the same angles on your x-axis, here's 0, here's pi over 2, here's pi, here's 3 pi over 2, here's 2 pi. But this time you looked at the x values as you moved around because the x is your cosine. Then your x starts at 0. At pi over 2, it's at, the x starts at 1. At pi over 2, the x is at 0. At pi, it's negative 1. At 3 pi over 2, it's 0. And then it would double back around to 1. So that's how this curve gets formed. Your cosine looks almost like an extended C, if that helps you remember the difference between cosine and sine. But cosine starts at the amplitude, then comes down to 0, then goes to the negative amplitude, then back up to 0, then back up to the amplitude. Everything else is exactly the same. So example 6 says determine the amplitude and the period of negative 2 cosine 4x. So just the amplitude and the period. What's the amplitude? Well, what's A? Negative 2. What's the negative going to do? Flips it upside down. What's the amplitude? Positive 2. We ignore the negative, right? It's just the absolute value. What's the B? 4. So the period would be 2 pi over 4, which becomes pi over 2. And then if it had said to graph this, I would go through all the steps. I would find my 5 key points, put them on the x-axis, and the only difference would be the overall shape of the curve. It's cosine and it's negative, actually. So it would start at the negative amplitude, work its way up, and come back down again. All right, go to example 7. This time it's got a phase shift, right? We're going to graph this one and graph. So A is what? 2, which means the amplitude is 2. B is 3. So the period is 2 pi over 3. And this time we have a phase shift, right? If I set this equal to 0, I get 3x equals pi and x equals pi over 3. So my phase shift is a positive pi over 3. Now I'm going to find my key points. So I'm going to just do it vertically on the side. You could do it either way. But I'm going to start at 0. And the last one is the period, which is 2 pi over 3. And then I take the 2 pi over 3 and multiply it times a fourth. 2 pi over 3 and multiply it times a half. And 2 pi over 3 and multiply it times 3/4. We were doing so good. There you go. So simplify here, and I get pi over 6. Simplify here, I get pi over 3. Simplify here, I get pi over 2. First one was at 0. Last one, 2 pi over 3. And if there wasn't a phase shift, those would be my key points. But this time, there is a phase shift. So I'm going to take that positive pi over 3 and I'm going to add it on to each of these. So I add pi over 3 add pi over 3, add pi over 3, add pi over 3, and add pi over 3. The first one should be your phase shift because you're taking it and adding it to 0. And then I get pi over 6 plus pi over 3. That becomes 2 pi over 6. So 3 pi over 6 or pi over 2. Pi over 3 plus pi over 3 is 2 pi over 3. Pi over 2 plus pi over 3. This becomes 3 pi over 6 and 2 pi over 6. So 5 pi over 6. And 2 pi over 3 plus pi over 3 is 3 pi over 3, which becomes pi. Now I'm going to plot them all on the x-axis. So the first one I have is pi over 3. So everything's to the right of my vertical axis. So the first one is pi over 3, then pi over 2, then 2 pi over 3, then 5 pi over 6, and then pi. And it's cosine. So this is where my shape changes. Instead of starting at 0, I start at the amplitude. My amplitude was 2. So cosine starts at the top, then goes down to 0, down to -2, up to 0, and up to +2. And my cosine curve would look like that. Yeah, sure. Questions on that one? All right, last thing we're going to talk about is the vertical shifts. The good news is literally all you have to do is add on one step, which is shift them up or shift them down. Everything up to this point stays the same. So if I have a trig function and at the end it says plus something or minus something, or it could also be at the front like 2 plus sine of x or -3 plus cosine of x. Sometimes it will do that to throw you off. If it's separated by a plus or minus and it's not inside the parentheses, then this causes a vertical shift. So I'm going to do everything we just did. A, amplitude. B, period. Key points, phase shift, plot it, then shift everything up or down, okay? The most important thing to pay attention to is if there is a reflection and a vertical shift. And in this case, the order you do these things matter. So if there's a reflection, meaning you're flipping it upside down, and a vertical shift, meaning you're shifting it up or down, you're going to do the reflection first. So you flip it, then you shift it. If you do it the other way around, you actually have to flip it over the x-axis instead of just flipping it upside down, which gets confusing, okay? So if there's a reflection, if there's a -2 sine of x minus 3, let's say, then I'm going to take my graph. I'm going to find my 5 key points. I'm going to draw the sine curve, which would start at 0, go down to -2, up to 0, up to +2, back to 0 first. Then I'm going to shift everything down 3 places. So it would come down 3 places. And then I draw my curve, okay? So flip it before you shift it. The order there is important, otherwise it gets confusing. All right, let's do one that does all of it together. So example 8 says determine the amplitude and the period of y equals negative cosine 4x plus 1. I actually think I'm going to just have us graph it and then we'll stop for the day. Yeah. All right, so what is A? It's actually -2. Remember the negative. I remind myself, this means flip it upside down. Okay, but the amplitude is what? 2. What's B? 4. So the period is 2 pi over 4, which is pi over 2. There is no phase shift. There's nothing inside the parentheses added or subtracted, right? But there is a vertical shift up 1. So on your test, you're going to get you're going to get your equation. It's going to give you a spot for you to give the amplitude, a spot for you to give the period, a spot for you to give the vertical shift, phase shift, and then on your actual graph is where you will plot your key points, okay? So I'm going to do the period, which is that pi over 2. Starts at 0, ends at pi over 2, and then I'm going to do pi over 2 times a half. Times a fourth. Pi over 2 times a half. And pi over 2 times 3/4. So my key points are 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. There's no phase shift, so I don't need to shift these over. If there is, I would do it before I plotted them. Pi over 2. Okay, and my amplitude is 2. Up 2, down 2. All right, so now it's cosine, right? Cosine, Priscilla, with us. Cosine typically starts up here, comes down, down, up, up. So my cosine curve would look like that, right? But there's a negative on the front. So instead of starting at the positive amplitude, we're going to start at the negative amplitude. So I go to -2, 0, 2, 0, -2. And this is what it would look like before the vertical shift. And then my vertical shift is in what direction? Up 1. So I'm going to take this whole thing and shift everything up 1 unit. So this gets shifted up 1, up 1, up 1, up 1, up 1. And the ending curve would look like that. Now, you don't have to have the one before it. Like if you didn't want to draw it and you wanted to shift it, you totally can. But I would say people make the most mistakes when there's a vertical shift and a reflection involved. So just be really, really careful. Questions? All right, we're going to stop there. The homework tonight is a PDF, okay? It is not on WebAssign. And I know it's brutal. I expect to see the work for these. I promise you this is one of those skills that is tedious, but if you practice it, you will master it, okay? Very rarely do I get a test that is left like either blank on this question or half done on this question, because you typically, by the time test rolls around, if we've done it today, you do it for homework, you do it for the warm-up, you do it for the review. If you've done it that many times, like it becomes like riding a bicycle. Literally, you can do this from muscle memory, okay? But if you don't go through the steps, that's when you get screwed up. You could totally check these answers on a graphing calculator. I don't care if you're like completely stumped and you need to check it. That's fine. Just realize obviously you won't have that for your test. And your test, you're going to do one full out sine, one full out cosine. And between the two, you will get a reflection or a shift or a vertical shift or a phase shift. So somewhere in between there, you're going to get all the different parts. Okay.